Okay, so this is homework 3, part 1, problem 2. And so in problem 2, we're given that x is a random variable modeled by the PDF of e to the negative quantity x plus 1 times the unit step function shifted 1 to the left. And y is equal to g of x, where g of x is equal to the absolute value of x from negative 1 to 1 and 0 otherwise. And so we can graph g of x as so. So it would have a slope of negative x from negative 1 to 0 and a slope of x from 0 to 1. And so this graph is going to prove to be very useful in the future when we continue doing this problem. And so in order to get, so in the first part we're asked to find and draw small f of y. And so small f of y can be found by using the fundamental theorem. Normally the fundamental theorem would be small f of y is equal to small f of x divided by g prime of x. But in our case, our g prime of x isn't continuous because there's discontinuity at 0. So there's actually two equations, one being x negative x and another one being a positive x. So we need to account for both of these situations by having multiple x's. And obviously if you had a different function, you would have to incorporate a third x. So small f of y now becomes equal to small f of x of x1 divided by x1 prime, the absolute value of x1 prime, plus f of x of x2 divided by the absolute value of x2 prime. And so like I said before, we can have x1 and 2 equal to positive and negative x. And so in my case, I used positive x for x1, and so the integral, or the derivative of x is simply just 1. Absolute value of that is going to be 1. So when you divide by 1, nothing happens. So it's e to the negative quantity x plus 1. And then for the second part, we substitute in negative x for x, and we get e to the negative x plus 1. And since it's small f of y, this all has to be in terms of y. So we just switch the y's for x's. If your equation, well in our case we could do this because it's y is equal to the absolute value of x. In the future, if y was equal to x squared, you would have to substitute in what y would equal to. In that case, if it's y is equal to x squared, you would substitute in the square root of y. But in our case, we just substituted y. So we end up with small y of y, small f of y is equal to e to the negative y minus 1 plus e to the y minus 1. And so this exists from 0 to y to 1 because y goes from 0 to 1. And so that's going to be the first part. And we know when y is greater than 1, it is going to be equal 0 because there's nothing up there. And when y is less than 0, because there's nothing down here, it is also going to be equal to 0. But now it's important to note that there exists an impulse function when y is equal to 0. And so in order to find that, we have to ask ourselves, where does y equal 0? Well, y equals 0 when x is either greater than 1 or less than negative 1. So in order to find the impulse, we have to take the integral of f of x from negative 1 to negative infinity. But this function does not exist from negative 1 to negative infinity because of the impulse function, because of the unit step function. So then we simply just have to take the integral from 1 to positive infinity of e to the negative x plus 1 quantity of x plus 1. And when we take the integral of that, we get e to the negative 2. And so we have at y equals 0 an impulse function of area e to the negative 2. And so this is the graph of small f of y. And we have an impulse function at 0 with area e to the negative 2. It's important to note that at 0 this does not equal e to the negative 2. Actually at 0 this equals 2e to the negative 1. And then going up to 1, at 1 this will equal e to the negative 2 plus 1. and it will be 0 otherwise, 0 less than 1, and 0 greater than 1. 0 less than 0, and 0 greater than 1. Alright, so that is small f of y. In order to find big f of y, we simply just take the integral of small f of y from 0 to y. And when we do that, we also have to remember to take into account the impulse function. So we have to take the area of the impulse function. But thankfully we already know that area. That's simply just e to the negative 2. And after we do the integral of the first part, we get e to the negative y minus 1 plus e to the y minus 1 minus e to the negative 1 when you substitute in 0 plus e to the negative 1 when you substitute in 0 plus e to the negative 2. So e to the negative 1 and minus e to the negative 1 cancel out, and we get finally big F of y is equal to negative e of negative y minus 1 plus e to the y minus 1 plus e to the negative 2. So when we graph this, when y is equal to 0, we get negative e to the negative 1 plus e to the negative 1. These two cancel out, and it's equal to e to the negative 2 when y is equal to 0. So this is a graph of big F of y. And it increases exponentially until it hits 1, where it equals 1. And afterwards, it continues to equal 1 because the summation of all your probabilities cannot be greater than 1. And so when you work a problem like this out at the end, and you find that the probability does not equal 1 at the very end, it is very likely that you just forgot to take into account impulse function during previous calculations. But yeah, so finally we have this is our big F of y is equal to negative e to the negative y minus 1 plus e to the y minus 1 plus e to the negative 2 from 0 to 1. It is 0 when y is negative, and it's 1 when y is positive.